know, I am working as an assistant professor in the Department of Aerospace Engineering at SNS College of Technology, Coimbatore. In today's class, we are going to learn about the terminologies in solid mechanics for aerospace. We are going to discuss first. One by one, we can start with. First, terminology. Start with the stress, which is denoted by the letter sigma. Generally, we are using the mathematical expression as a load by area, that is the stress. But we should not define. We have to define the stress is the resistance offered by the material to meet the load. If we are applying a load on the material, how much load the material can withstand, and it will give the resistance for the deformation. Okay, if it can withstand more amount of load, then the stress level is reduced. Okay, so like that we have to define the stress, the resistance offered by the material to meet with the load. Then we can have a expression, mathematical expression for stress, that is equal to load by area. Load by area. Here we are using P as the load, A as the area. And one more thing, we are having here the denominator area. This area we have to concentrate only on the cross-sectional area, not the surface area. Okay, when we are applying the load on this face, so this area we have to take care of, this length into width. If it is the like a circle, then the cross-sectional area will be the circular area, pi d square by 4. Like that we can have it. Then what are the unit for stress? Unit for stress is Newton per meter square. Since this load is measured in terms of Newton and the area is meter square. So this is about stress. Then we can move on to the another terminology called strain. So we can have another terminology strain, which is represented by the letter small e. Okay. So here the strain is nothing but the change in dimension to the original dimension. Okay. The change in dimension to the original dimension. Generally, this strain is always called a simple strain or longitudinal strain. Otherwise called a linear strain. Okay, so we are using this linear or longitudinal strain. So we are focusing the measurement as length. Okay, so we are going to use the change in length to the original length. So we are applying load. We are applying load, so it can have a deformation. So it can stretch it. So some amount of increment in the length. Okay, so we are going to use how much increment in length to the original length. Okay, so that kind of mathematical expression for we are using for measuring the strain. Then what about the unit here? So unit is no unit, since it has the ratio of same parameter. Okay. Then we are having another terminology called lateral strain. Another called lateral strain. So it should be specifically given lateral strain. So we can simply represent this E as the lateral. Okay. So now I used only length for linear strain or longitudinal strain earlier. Okay. Now we are going to concentrate other than the length. So we are having this much thickness or this phase of the width. Okay. Now instead of this length, we are going to concentrate this phase. So changing the width to the original width, that is called lateral strain. Otherwise called when we are going to use the thickness. Okay. So we are going to use E lateral as change in dimension. Here we are going to use the diameter, change in diameter to the original diameter, change in width to original width, like that we can take. But this change in length to the original length, if you are taking, this is wrong for lateral strain. This is for the longitudinal strain or simple strain. Okay. So here also it is a strain. So unit is no unit. Then we can go on to another terminology. Then we can go on to the another one called Hooke's law. Hooke's law. So we can, how it can be stated? So it can be stated that the stress is directly proportional to strain. Stress is directly proportional to strain. But it should be given within the one condition called within the elastic limit. Now we are going to apply the load, so we have an elastic limit. Up to the elastic limit only this Hooke's law is valid. So within the elastic limit is a very important term here. Within the elastic limit. Okay. So stress is directly proportional to strain. Then it can be used as, okay, you can remove the directly proportional symbol. So I am going to introduce a new constant. That constant is called Young's modulus. Okay. So this Young's modulus. Young's modulus is a material property. So it depends only on the material. Okay. Young's modulus depends only on material. What is the significance of Young's modulus? The Young's modulus, if the value of the Young's modulus is higher, what happens? Okay. So it gives the resistance for bending or deformation. Okay. It gives the resistance for deformation. If the value of the Young's modulus for a particular material is higher, you can apply more amount of load so that deformation will occur. Okay. For steel, the value of the Young's modulus is higher than the aluminum. Okay. So aluminum will tend to bend or deform easily for a low amount of or lesser amount of the load. Okay. But steel, we need more amount of load than the aluminum. That is the significance of Young's modulus. The another terminology called the Poisson ratio. Poisson ratio. So Poisson ratio generally it is represented by the letter called mu. Otherwise it can be written as 1 by m. This m is not refer to any parameter or any terminology. Some representation they are giving. If m is equal to 3, then what is the Poisson ratio? 1 by 3. That is 0.33. So like that. So how can we define? This Poisson ratio can be defined as lateral strain to the linear strain. Again, lateral strain to the linear strain. That is called the Poisson ratio. If you are applying a load here, it will tend to stretch, so the incremental length will be there. At the same time, this transverse direction or lateral direction, okay, it can be tend to be decreased. Okay. So when applying the load, there will be a change in length as well as the change in the transverse direction dimension also. The ratio is called as Poisson ratio. We will have a positive value, that is for most of the engineering materials. This mu is equal to 0.3 to 0.5. For most of that engineering materials, this Poisson ratio ranges from that. Okay. Then another strain is called volumetric strain is there. Volumetric strain. So volumetric strain it can be also represented by E suffix V. V refers to volume. It is also change in volume to the original volume. Change in volume to the original volume. So that strain is called a volumetric strain. Finally, we are moving on another parameter called bulk modulus. Bulk modulus. Bulk modulus is represented by the letter K. Actually, this K bulk modulus is equal to minus V into dV by dV. Generally, it is called. Then I think that due to the pressure, okay, if you apply that pressure, there is a variation in pressure. Volume is changed. Okay, so it can be represented. What is the change in pressure? Apply whatever the volumetric strain. So generally it is called dV by dV. This is volumetric strain. This is change in pressure. So this V goes to the numerator. What is this negative sign indicates? This negative sign indicates that if pressure is increased, the volume gets increased, as vice versa. Okay, so that whether there is an increment in pressure, there is an increment in the volume. So that the negative sign indicates here. So, going to summarize this class, what we have learned in this class. Okay, so we have learned what is strain, what is stress, what are the different types of strain. That is simple strain or longitudinal strain, lateral strain, volumetric strain, and bulk modulus. Then Cook's law also we have studied here. Okay, so we will have another important topic in the next class. Thank you.